Mains electricity. Alternating current changes direction, unlike direct current that always travels in the same direction. So here we can see electrons in a wire carrying an alternating or AC current. The electrons are just jiggling backwards and forwards. In a direct current or DC, the electrons are always travelling in the same direction, from the negative towards the positive terminal. Mains electricity is alternating current. It has a frequency of 50 Hz. Time period is 1 over frequency. 1 over 50 Hz means a time period of 0.02 of a second. Here we have a graph of potential difference against time, and this line is showing the potential difference of the live terminal of the mains. The mains is quoted as having a potential difference of 230 volts around here, but as you can see, it has a peak potential difference of plus 325 and minus 325 volts. The 230 volts is called the root mean square value, or RMS. It's the value of a DC potential difference that would give the same power. You can imagine that the voltage above 230 volts here could fill in the gap where the potential difference is below 230 volts here. The neutral terminal stays at or close to 0 volts. So this could show the neutral terminal potential difference against time. The earth is at 0 volts and will only carry a current if there's a fault. We'll look at the earth line later. So this would show the potential difference of the earth with time, just constantly at 0. Here we have a picture of a plug. You'll see on the right we have the live wire. This carries the alternating potential difference from the supply. You'll notice that the wire is brown, and BR for brown tells us that it's at the bottom right. You'll notice the fuse here, and also any switches, are in the live side, the live being the most dangerous side. On the left hand side we have the neutral wire. This completes the circuit. This is blue, and BL for blue reminds us that this wire is on the bottom left. On the top here we have the earth wire. This is a safety wire which will stop the appliance becoming live under certain circumstances. This is covered later. The earth wire has green and yellow stripes. The live wire can be dangerous even if the switch is open, as the switch will only isolate the wire after the switch. Also, it might have been incorrectly fitted in the neutral side. It would still work as a switch, turning the appliance on and off, but would not make the appliance safe. If a person makes a link between the live wire and earth, a large, possibly fatal current can pass from the live to the earth through the person. Here we have a typical wall socket circuit from a house. Here we have the live wire, the earth and the neutral going to the fuse box, and beyond there to the power station. You see the live wire comes round in what's known as a ring main to the bottom right hand socket of several wall sockets. The neutral wire is the bottom left and also comes around the ring back to the fuse box, and the earth is connected to the top pin. Here we'll see the operation of the earth wire and the fuse. I've taken one of the connections to the socket, so we have the live wire, the earth and the neutral coming to the plug socket. The washing machine is plugged in and we have a live wire coming to the motor. Here the live wire has broken loose and is now touching the metal casing of the washing machine. A person has come up to find out what has gone wrong and touches the casing. There's now a path of current to flow from the live wire through the person to earth. So it can go through the casing of the washing machine, through the person, down to earth, literally to the ground. This could give them a fatal electric shock. With an earth wire fitted, you'll see the earth wire is connected to the metal casing of the washing machine and is also connected to earth. So now, when the live wire comes loose and touches the case, there's a low resistance path direct to earth. A huge current flows and almost instantly melts the fuse, so breaking the circuit. So the current can now flow up the metal casing, along the earth wire, down to earth. Appliances with a plastic case, such as a hairdryer, doesn't have an earth wire, as the casing cannot become live. I now have a few pictures of plugs that have been incorrectly assembled. You could stop the video while you identify the problem. In this case, the cable grip here has a screw missing. The cable grip should go around the outer insulation to prevent any tugging of the electrical connectors here, here and here. In this case, there's too much cable exposed at this point. There should be about this much cable, so you can ensure that the plastic insulation is not under the grip screw here. In this case, the live and neutral need swapping. The brown should be at the bottom right, connected to the fuse, that is the live. The blue should be bottom left, connected to this pin. In this case, there's no cable grip at all. In this case, the cable grip has gone over the inner insulation, not the outer insulation. This won't grip the wires properly, leaves this area short of a layer of insulation, and could lead to pulling on the electrical connections. In this case, the wires are just too long. This wire here, for instance, could end up being trapped between the base here and the lid, as could this one. In this case, the insulation is damaged at this point. That can't be repaired, you'd have to cut the wire back and start again.